All right, let's get right into it. Before we start, remember that if you're interested in getting access to Materialize and you're not already activated with an account, we're happy to set you up with a free trial, plenty of credits to learn the basics or prototype. Or if you'd rather just connect with someone from our team and talk through your use case, we're happy to do that too. For either, just go to our website, materialize.com, and it should route you to the right place. In fact, one of the people you might end up talking with is our speaker today, Josh Ehrenberg from the field engineering team. I'm really looking forward to this because Josh has a ton of hands-on experience in two particular areas that are relevant to this topic. First is running and scaling data teams. I'll let him go into more detail about that, but suffice it to say, he has many years of experience in a number of different businesses that really allow him to draw from real world for his talk today. And then also, the second is running and scaling Materialize. He'll downplay it, I'm sure, but Josh was years ahead building real-time data infrastructure on Materialize and powering not just reporting and analytics, but closed-loop automation at his previous employer, Datalot, and now Centerfield. So without further ado, I'll hand things over to Josh. And one last thing, if you have questions, feel free to drop them in the Zoom throughout, and we'll get to them at the end. All right, over to you, Josh.
All right, thanks a lot, Andy. And yeah, thanks everybody for joining. Really happy to be here today. I'm Josh. I am a recent joiner at Materialize, a member of the field engineering team, so helping people get onboarded onto Materialize. Before that, I have worked at several startups, as a VP of data engineering manager, this sort of thing, doing a lot of stuff with real-time data and distributed data, and then spent a long time as well doing application, development team management, at some medium-sized companies and in like big corporate situations too. So I've sort of come at this problem from a number of angles, especially starting to think about data teams more as application teams. I'm like naturally interested in that. What's the problem that I'd like to talk about today? I'd like to talk about managing complexity on data teams. And this, I think, is something that I'm hearing about a lot with the folks that I'm talking to, and something that I've experienced firsthand as well. And that is that the data team is quickly becoming a bottleneck in a lot of organizations. And I think if you look at it, it's, one of the few remaining like big centralized teams that you have to go to in a lot of organizations to get things done. The data teams are growing in general. Requests for data are more numerous and coming from further down the org chart. People are asking for analytic data to do all sorts of different jobs at organizations these days, not just big roll-ups for the C-suite at the end of the day, but using data, I mean, as I'm sure everyone knows, all over the place. And then and this can become a bottleneck, and especially so in situations where you have company mergers. I think, if you've been involved in a company that's done a lot of mergers, I mean, you can see, enormous problems in trying to bring data models together, especially if you've taken a strategy of, a big centralized data model, a data mart, and experienced a sequence of mergers. You can see teams sometimes falling years behind in integrating data, generating answers from that data. So it's a real problem. And I think that and there's a lot of pain, around integrating data, around access to data. You need the engineering team to be on board. You need the full data team to be on board, the leadership of the organization to be on board in order to make it happen. And I think that's part of why thinking about how we can take steps towards it to prepare for it is important. There are also technical barriers that make it challenging. And I think, in fact, the idea itself is one that has almost been considered an anti-pattern traditionally in the industry, that you would have sort of these lots of individual data sets rather than sort of one central data store. It can be thought, has traditionally been considered bad practice, and we'll look at some of the things that data mesh does to sort of try to ameliorate some of those problems and address them using both like tools and technology to try to avoid. We're not creating data silos here. We're creating a distributed system, right? And then the last thing is that it's still very much early days for these ideas. I think and this is borne out, certainly I'm talking to a lot of folks in my current role at Materialize, right? And my experience, I haven't seen like wide adoption of data mesh yet or anything, but although I hear a lot of talk about it, so I think there's still a lot of it's still difficult enough that it's not being done everywhere yet. So the way I want to sort of go through this is data mesh is built on 4 main principles, and I want to kind of use those as a lens to look at both what is the concept, how can we sort of take steps towards it, and then also how does Materialize sort of fit in to these principles into distributed data team world. Now, these 4 concepts are cumulative, but that doesn't mean that you sort of adopt them one at a time, but they do sort of build on each other. So the first one we're going to look at is the idea of domain ownership. And this is probably the most fundamental principle. And it's the idea that we're going to do analytics close to the data production, close to the source. And this includes the idea that the data product owners and the data product managers are going to sit in the sprints with the application developers. They're going to be tracking the OKRs. They're going to be very involved in the development process. Because it's a smaller scoped problem, the idea is that it's a smaller loop. So for example, if your application team is looking to make an upstream schema change in the transactional database, the idea would be that your domain owner is going to be aware of that. They're going to be in the discussion when it's being considered, and there's going to be tests and outcomes to make sure that those changes not only don't break the application itself, but don't break the downstream data product, which is now being managed as part of the same work product. So let's take a look at some of the steps that we could take to move sort of incrementally towards domain ownership. I think the first one is the idea of assigning data team members to functional areas. And this could, in the very early stages, just being like, hey, pick a subject matter expert for each one of the data domains. And this is probably something a lot of people are doing already, but you could sort of make it official, or you could do like dotted line reporting kind of things. I think the idea is that you make it very apparent that someone's main responsibilities include sort of tracking one functional area and being ahead of any changes there, and really understanding the data picture there, and then also becoming responsible for any new requests for data in that area. The second one is, I said, sort of start attending sprint planning, tracking OKRs, this sort of thing, like getting further enmeshed in that team. Now you're talking to the application teams and bringing them into the plan, right? This person is starting to be thought of as a member of that same team, right? Break out analytical data sets along domain lines. This is probably the most difficult one, right? Especially if you're working if you have some really big central data mart that you've been working in for years, breaking things out into separate data sets is going to be a project, but it's one that could be approached incrementally. And then lastly, transferring ownership of the data to the domain owners. So let's take a look at how Materialize might come into the picture here, how it might be useful. I think there are a few things in the Materialize architecture that are really going to help here. One is that it's a distributed architecture, right? So you can, within Materialize, all of the work is being done on clusters, and I would have each domain team with their own cluster with their own ability to control the code for those analytics and managing it that way. Domain ownership describes three different types of data. One is analytic data, one is source data, and then one is sort of specialized end user data. So source data is sort of the upstream data. This is like the raw transactional data, the business level data. And this data, even with data mesh, they don't recommend you going for example, transactional database to the actual source repo for this data. Materialize kind of makes a great layer of indirection here, because even if in a case where you're not doing analytics or anything like that, you can still have a layer of protection against schema changes, right? And you have sort of low latency access to this data, right? Materialize can consume it and present it in real time. And you can change the format of the data if necessary for the end user, but you're not adding risk by having additional people connecting to the transactional data source. And then of course, Materialize is well suited for analytic data. That's sort of its whole raison d'etre, if you will. It's very good at doing aggregations, summarizations, data mart style manipulations on data and presenting it in a way that is easy to consume. And we'll talk about that piece a little bit in the next point. But another thing that I think is very key to using Materialize this way is the cross-product access, right? So because now you're splitting up your data into these multiple data products that are managed by these multiple domain teams, it's critical that one data domain can consume data from another domain, and that you have the ability to join that data together, build data products that consume other data products in novel and flexible ways. Materialize is a great choice in that way. By using Materialize used on separate clusters, you can very much join data together, use it together, right? And then access control, full RBAC is coming very soon in Materialize. It's actually code complete at this point and behind a feature flag, so you should see it hitting in the next few weeks. And I know that's something that a lot of people have been waiting on. Here's just kind of a picture of what this would look like, the before and after. And this is like a super simple implementation. Before would be sort of a central data mart strategy where you have multiple sources coming in, being aggregated into a data mart, and then queried. The after picture just shows where you would have several data products. And in this case, you've got two that are sort of upstream data products working with source data, right? Probably doing some level of aggregation on them. And then a downstream data product that is consuming from those two. And an important point to realize here is that you'll notice there are arrows of people querying all of these data products. So the idea is not to just do the processing upstream and have it flow downstream like you would in sort of a traditional data pipeline, but that you have people sort of accessing these data products directly as needed. All right, so data as a product is the next principle of data mesh. And this is the idea that data sets get promoted to be first-class citizens in a product organization, right? So they now have attention from product managers. There are ownership responsibilities, there are developer responsibilities, there are testing, and there's a number of criteria that we're gonna measure a data product with and make sure that it lives up to a set of standards. So it means that we're sort of elevating the level at which we're maintaining data. The principles that they talk about are that it needs to be addressable, meaning that there need to be like easy ways for self-service access to happen. Understandable, meaning that people can understand that there's clear intent and documentation around what's in a data product. That it needs to be truthful, so that there's test and that it's that its data freshness is being monitored. That it's composable and interoperable. And this is sort of what we were getting at a minute ago with these data products sort of stand on their own, but they're also going to be interdependent. So they need to be secure. We need to track provenance and lineage. And then in addition, there are some new roles that come along with maintaining these data products. So the role of data product owner, who's sort of responsible for sort of the full set of responsibilities, the data product developer, who is the person who is sitting on the development team, whose primary output is the data product itself. So let's look at some steps that we might take to move towards treating our data sets as data products, right? First one is decide which data sets are going to be promoted to data products, right? So this is probably a filtering effect. If there's a bunch of like old and dead tables around and that sort of thing, or reports that nobody uses anymore, right? Those aren't good candidates for data products. Like, you're going to be selective. The next thing is get documentation and accessibility of data products up to an agreed upon standard, right? So this is sort of par for the course, right? And then start tracking changes to the products as part of the domain team alongside Eng, right? So this is kind of where it makes that step from being just another set of data that's out there that was created by the data team to being something that's actively managed and maintained by the data team, that is being tracked by the same way that you would track like a code base and maintain a code base. And then lastly, set up systems of accountability around product standards, right? So this is where you're actually building out those functional roles, and that's sort of the last level. So let's look at how data as a product works with Materialized. The first point is a really important one, and I think one where Materialized particularly stands out compared to a lot of other options. So as you probably know, Materialize is a streaming database, right? This means that by building your data products as Materialized views, you get sort of a few properties there, right? One is that the whole conversation around the freshness of the data is off the table because it's maintained in real time, right? There doesn't have to be any agreement between stakeholders about how often to refresh this data set, how often are we running dbt run? No, you sort of don't have to worry about that because the data is always being maintained up to date incrementally, right? The second thing is that Materialize gives the end user of your data product a bunch of choices about how they want, how they're going to access the data, right? As you probably know, with Materialize, you can access a Materialized view using the Postgres protocol. You can treat it as a database and run normal select queries against it, right? So in that way, it's very familiar and compatible with lots of things. Secondly, it supports subscriptions using the Postgres protocol. So if you wanted to, rather than a pull-based model, you can switch to a push-based model where Materialize is pushing the data set downstream. So for example, if the consumer of your data product was building a real-time UI, they could point it directly at Materialize. This is something where I think Materialize really stands out, is that you can build applications on top of it, not just sort of end user queries and that sort of thing. And then lastly, we have syncs, which is basically just pushing it downstream, typically via Kafka. Probably in the future, there will be more options for sync besides Kafka, but like the idea being that it could participate as part of like a streaming pipeline. So, and the great thing is, you as the data team owner don't have to make that decision for the clients. By it being a Materialized view, everybody can kind of choose how they want to consume that data. And now I'm going to conflate a few things here. As some of you guys probably know, Materialize supports dbt, and I'm going to, for a lot of elements in this talk, lean pretty heavily on that because dbt is doing a lot of great things in this space. And so dbt is, for those that I think probably most people have seen it, but it's a way to maintain your SQL as code and provide a lot of functionality around automating. In the case of Materialize, it's great for automating deployments. It's great for building macros and all sorts of other things. And one of the things that we get from dbt, and that we actually have a dbt Materialize module for dbt that allows you to run real-time tests. And this, I think, is a powerful tool for understandability and truthfulness of data. So it could allow you to have a suite of tests running on your data products that are sort of doing real-time alerting if you ever break a constraint. So it could really allow you to to build up truthfulness and trust in these data sets. Correct answers, right? Seems like a fundamental thing, but especially if you've done a lot of work in the world of streaming data, it can be easy to run into problems around slow streams causing subtly incorrect answers. And so one of the great things that you get from Materialize is support for strict serializability and a focus on correctness through the product. And a lot of that comes from the timely data flow underpinnings of the system. So composable and interoperable, we talked about that a little bit, but you can also see that by being able to express all of the data products probably today in a DBT mono repo. Actually, DBT has just announced, like as of last week, support for like a bunch of these principles. They're obviously very focused on this data team distribution problem as well, because they're going to be offering support for basically having different DBT code bases that are dependent on each other. I mean, personally, I think you can get a long way with a mono repo. Just ask Google about that one. But like, if you wanted to break each data product out into a completely different code base, but have them be able to consume from one another and to be able to do like schema checking across these code bases so that an upstream data product cannot build a version of the code that's going to break a downstream data product, and things like that are going to become increasingly possible. And then lastly, it's got to be secure, right? And I mentioned support for RBAC is coming, SSL, encryption at rest, and in motion. We have all of those. All right, the next principle is self-service platform, right? Basically, the data mesh states that there should be sort of one main data platform that everything talks to. Is very aspirational in this sense. Like, this is a very hard thing to do, especially if you have multiple data platforms. Now, one thing you could say is like, hey, if you're in a world where like Materialize is your only data platform, which would be awesome, but then Materialize probably meets a lot of the requirements of the self-service platform, certainly not all of them, but more than likely in a large enough organization, there are going to be multiple data products, right? And in that case, like this would sort of be this sort of meta layer that is handling data discovery, data access, data transformation, data analysis, metadata, governance. They want to put sort of access to all that stuff into one platform. I think it's a really hard problem. There's starting to be some products in the market that aim to do this, but I think it's early days yet, is my feeling. So the way to think about this right now is like, well, how many of these principles, one, can Materialize approach, but two, we should build on top of open protocols so that if we one day do find ourselves adopting one of these big data mesh self-service platforms, there's a good chance that like the systems that you're using under the hood are going to be compatible with it. So what are some of the steps we could take towards self-service platform? Limit the number of underlying systems, right? Like this is going to be a huge integration effort whenever you try to do it. And the less things you have to integrate, the better. Standardize on platforms with open interfaces, right? That's just going to increase the chances that when you do a data platform, it's going to work with the stuff that you have. Start building up capabilities around metadata, right? Things like data lineage, data dictionaries, that sort of thing. All these products in this space, I think, are going to come eventually under this data platform and allowing people to work in a self-service manner with your data. And then the last step would be actually move on to a self-service platform once they've reached maturity. Maybe they're there today. I don't know. I certainly haven't seen it yet, but there's definitely some that are starting to move in that direction. So self-service with Materialize. Support for Postgres protocol. That's the biggest one, right? I think that sort of says like at some point, there's a good chance your self-service framework is going to work with Materialize. Support for DBT docs. This is an important sort of step in that direction. It allows you to document your tables and your columns. It allows you to see data lineage. So it gives you a bunch of these features, at least within the Materialize world. And if Materialize is your only analytic data platform, then maybe you could say Materialize is your self-service platform. We'd love to hear it if that's the case. And then just the SQL interface. Right, the self-service, the Materialize self-service platform talk a lot around building an interface for a generalist majority. I think SQL, in a lot of organizations, SQL is that. Certainly not all, but it's sort of a company culture thing. And then the last point that I'm going to hit on is around federated governance. This is much more of sort of the people side of the picture. It's around creating data policies for the collection and storage of data, for data around compliance, around monitoring data quality, managing access, resolving disputes about the data, all this sorts of thing. And the idea here is this is not some like group of governing overlords. The governance team is made up of all the members of the domain team. So the idea is you're coming together on some sort of regular cadence and building up the policies. And this is how you get standardization. This is how you make sure that you can maintain interoperability for the data and that you're following legal and compliance and all that fun stuff, right? Nobody likes to talk about governance, but at least this is a democratic approach to that problem and made up by the individual members, the data owners and the data developers of the individual teams. And then what steps can we take towards this, right? Some of these kind of obvious: set up regular meetings between the data product owners and the central team and the developers, start codifying basic standards based on existing practices. As teams become more autonomous, bring in more subject matter experts. That's your legal and compliance and that sort of thing. And then lastly, build up a regular process for decision making across the domains. And so that's when you're sort of like into fully autonomous data mesh mode, right? How does Materialize fit into this picture? Potentially support for continuous testing. We talked about that a little bit. Could provide a very good mechanism for tracking compliance with these standards. Support for RBAC, obviously table stakes. And then data expiration. This is one that's maybe a little less obvious, but like one nice thing about a real-time system that supports retractions, and by support retractions, I mean, if you delete a row in one of the upstream sources, Materialize will guarantee that that row gets deleted in all fully downstream through the DAG. So for a lot of your data compliance, GDPR, all these types of things where you need to make sure that this data isn't like sneakily still hiding in this data set or that data set or this data product or that data product. With Materialize, if you delete something from the source, it's immediately going to be retracted from all of the data products. So that's a nice feature for supporting a lot of these policies. All right, so that's it. I really appreciate everybody joining today. I hope this was useful. We touched on a bunch of things, hopefully got a good sort of basic introduction to data mesh. Obviously, it's a topic you could easily do a week-long course on, but we hope that this at least gives a little bit of a flavor how you can start to adopt some of these principles, maybe start to make moves in this direction, and how Materialize might be able to help.
Thanks, Josh. This was super useful. We will be sharing out the recording of this. It should be tomorrow, and putting it up on YouTube if you want to share it out or go back and check anything you missed. And thanks again for your time today. And don't forget, register at materialize.com if you're interested in getting access. All right. Thanks, everybody. Thanks, Josh.
Thanks.